Hello, this is a past paper for component 4.2 for IGCSE, October-November 2019. Question 1. Figure 1.1 is the top view of a rectangular pavement pool of constant depth. The pool is filled with seawater. The volume of the seawater in the pool is 264 meter cube. Calculate the depth of the pool. Okay, first of all, we should find area of rectangle. So area of rectangle is 44 times 20. So we will get 880 meter square. Then volume is equal to area times depth. That's why depth is equal to volume divided by area. So volume is given 264 and area is 880. So if you divide, you will get 0.30 meter. Part B. The mass of the seawater in the pool is 2.70 times 10 to the power 5 kg. Calculate the density of the seawater. Give your answer to three significant figures. Okay, so formula of density is mass over volume. So mass is given, volume is given from part A. So if you divide, you will get 1020 kg per meter cube. Part C. Calculate the pressure due to seawater at the bottom of the pool. So pressure is equal to density times G times H. Density is given, rho is given, 1020. G is nearly 10 and depth is 0.3. So you will get 3100 Pascal. State a suitable instrument for measuring the dimensions given in figure 1.1. So you know that because dimension in part A is 20 meter and 44 meter, that's why we should use tape measure. Question number 2. State two conditions which must be true for an object to be in equilibrium. We know that there are two conditions. Number 1, no resultant force acted on object and no resultant moment. It means some of the clockwise moment should be equal to some of the anti-clockwise moment. Okay. Next part. Distance PQ is given, this is 100 centimeter. Mass of meter rule is given, 0.12 kg, and weight is W. First of all, you should draw an arrow to show the force acting on PQ at the center of the mass. Okay. PQ is 100 centimeter. If you divide, you will get center of mass. So at 50 centimeter, you should draw arrow of weight, as I did. You can see that this is W is in the middle of the this rod, and then an arrow to show the force R acting on PQ at the pivot. So you know that at the pivot you should draw a force upward, because at pivot a force exerted upward, so R should be upward. Next part. By taking moments about the pivot, calculate F. As I said, sum of the clockwise moment is equal to sum of the anti-clockwise moment when rod is in equilibrium. So clockwise moment, we have 1.2 times 40. So this is 1.2, 1.2, 1.2 is the weight times 40. distance to pivot. Then anticlockwise, there are two moments for anticlockwise. One of them is 0.5 times distance to pivot, 0.5 times distance to pivot, and the second one is F times distance to pivot. So F times 90 centimeter. So if you calculate, you will get F. F is 0.48 Newton. So in this kind of questions, you should consider weight of the rod. This is one important point. And the second is that you should consider, if rod is in equilibrium, you should consider conditions for equilibrium. So as you can see, part 2 and part 3, in part 2 I use one of the condition of equilibrium, and in part 3 to find R I used another one. So sum of the upward forces is equal to sum of the downward forces. So if you look at figure, R and F, they are upwards, and 0.50 and W are downwards. So sum of the upward forces, which means R plus F, should be equal to W plus 0.50. Then you can find R, which is 1.2 Newton. Question 3. Figure 3.1 shows a gas contained in a cylinder enclosed by a piston. Describe in terms of momentum of the molecules how a pressure is exerted on the walls of the cylinder. So if you look at your syllabus, you can see that what is the cause of a gas pressure? Cause of a gas pressure is exactly answer of this question. As you know, molecules collide with walls of the container and they bounce back. Change of momentum causes force exerted on walls, because you know that when there is a change of momentum, there is a force, because change of momentum over time taken, it gives you force. Then you know that pressure is equal to force over area. So force over area of the walls of the container gives you pressure inside a container. Part B. The piston is pushed into the cylinder, then the volume decreases from 820 to 330 centimeter cube. Pressure gauge measures the pressure after compression as 200,000 Pascal. The temperature remains constant. So when you see in those questions, when you see constant temperature, you should use Boyle's law. So temperature remains constant. You should use Boyle's law. What is Boyle's law? Boyle's law is P times V, pressure times volume, is equal to constant. So it means P1 V1 in first condition is equal to P2 V2 in second condition. P1 is not given, but volume is given, 820. P2 is 20,000 times volume in second situation, which is 330. So if you calculate, you will get P1, which is 8,000 Pascal. So if you consider when pressure is 8,000, volume is 820, and when pressure is 20,000, then volume is 330. It means pressure is inversely proportional to volume in Boyle's law. Question 4. A student carries out an experiment to determine the thermal capacity of a metal block. The block is heated by an electric heater for 23 minutes. The current in the heater is 3 ampere at the potential difference of 12 volt. The temperature of the block rises from 20 to 70 degrees Celsius. Calculate the thermal capacity of the block. Okay. You know that energy is equal to power times time. So E is equal to PT. And you know that power in current chapter is equal to IV. So energy is equal to IVT. I is given, V is given, T is given. You must convert to second, then you will get 49,680 joules. Next part, it is said that calculate the thermal capacity. So you got energy, which is heat in this question. So what is thermal capacity? Thermal capacity is M times C, mass times specific heat capacity, which is equal to heat divided by change of temperature. Because as you know, heat is equal to mc delta theta. So what is thermal capacity? Is equal to Q divided by change of temperature. And instead of heat, you can write energy, because heat is a kind of energy. So you will get E divided by change of temperature. Unit of thermal capacity is joule per degree Celsius or Kelvin. Instead of degree Celsius, you can write Kelvin. So this is unit of thermal capacity. So energy, you got 49,680. If you divide by change of temperature, you will get 990 joule per degree Celsius, which is thermal capacity. Next part. Two metal spheres of different diameters are heated to 900 degrees Celsius in a hot oven. The two spheres are removed from the oven. State and explain any difference in the initial rates of emission of radiation of thermal energy between the two spheres. First of all, this kind of question said state and explain. State has 1 mark and explain has 2nd mark. So this part has 2 marks. So what is the answer? You know that larger sphere emits thermal energy more. So you can get 1 mark because of writing larger sphere emits thermal energy more. Why? Because it is said explain. Because of larger surface area. You can get 2nd mark because of writing of your explanation. So larger sphere emits thermal energy more because of larger surface area. Then you can get 2 marks. Second part. One hot sphere is now heated in a hotter oven. State and explain any effect on the rate of emission of radiation of thermal energy from that sphere when it is removed from the hotter oven. It is said state and explain any effect on the rate of emission of radiation. So if you put it in a hotter oven, you know that because of larger surface area and also higher temperature, you will get greater rate of radiation. So greater rate of radiation. Question 5. One difference between a longitudinal wave and a transverse wave is that a longitudinal wave consists of the compressions and rarefactions. Explain the terms compression and rarefaction using ideas about particles. So you know that in compression, particles are closer to each other. So you can write it, particles are closer. You can get 1 mark for this part. And the second part is rarefaction. So for rarefaction, you can write it, particles are further apart. So in rarefactions, particles are further apart. In compression, particles are closer. Describe one other way in which longitudinal wave motion differs from transverse wave motion. You know that in longitudinal wave motion, vibrations are parallel to direction of the wave motion. So vibrations are parallel to direction of the wave motion. In transverse wave, vibrations are perpendicular to direction of the wave motion. So this is a one difference. If you write, you will get 2 marks. Another difference is that for longitudinal, medium is required. For transverse wave motion, medium is not required. This is the second difference. If you want to write, it is optional. You can write first difference or second difference. Part B. A sound wave of frequency 0.120 kilohertz travels through a rock at a speed of 3,500 meters per second. Calculate the wavelength of the wave. You know that what is the equation of wave motion? It is V is equal to F lambda. F is frequency, lambda is wavelength, and V is a speed. So if you rearrange, you will get lambda is equal to V over F. V is 3,500 and F is 120. If you divide, you will get 29 meters. So wavelength is 29 meters. The wave travels from the rock into the air. State and explain whether the wave will be audible to a healthy human ear. Okay. So you know that frequency in this question is 120 hertz. 120 is between 20 and 20,000, because you know that range of audible sound is 20 hertz to 20,000 hertz. That's why 120 is between 20 and 20,000. So you can say, for a statement, you can say yes, because audible range is 20 to 20,000. And in this question, frequency is 120. And for explanation, you can say that frequency doesn't change in different medium. So if wave travels from the rock into the air, frequency doesn't change. Question 6. Figure 6.1 shows an empty container and observer's eye. There is a small point at position O. The observer is unable to see the coin. The observer and the coin stay in the same position and the container is filled with water. The observer can now see the coin. Explain why the coin can be seen by the observer. So if you can see in figure 6.1, these are water inside container. So now there are two mediums. One of them is air, one of them is water. Because of difference of refractive index, when light comes to the boundary, refracted, and because air is less dense comparing to water, that's why refracted ray goes away from the normal. So suppose this is a normal. So if this line is a normal, refracted ray goes away from the normal. So remember that if a ray comes from denser to less dense medium, in the boundary, first of all, it is refracted, and second of all, it goes away from the normal in less dense medium. That's why observer's eye can see coin at position, can see coin, not at position O, because of apparent depth, position of coin will be changed a little bit. But now observer's eye can see coin, or you can say can see image of coin. So you don't need to write explanation, but if you want to know, I wrote that because of light from coins comes to the boundary, bends away from normal because it comes from denser to less dense medium, and so it reaches to the observer's eye. So ray reaches to the observer's eye. Next part. State the name of the wave process. You know that it is refraction. Explain why the image of the coin is the virtual image. One reason you can write it because the image cannot be seen on a screen. You can write many reasons for this part. One of them is that because the image cannot be seen on a screen. That's why it is virtual image. State the speed of light in air. It is 3 times 10 to the power 8 meter per second. Part C. Refractive index of water is 1.3. Calculate the speed of light in water. You know that refractive index is equal to C over V when one of the medium is air. So 1.3 is equal to 3 times 10 to the power 8 divided by V. If you rearrange, you will get V is equal to 2.3 times 10 to the power 8 meter per second. So to know more about refractive index, I proved that refractive index is inversely proportional to a speed of light in that medium. So suppose there are two mediums. One of them is N1, velocity of light is V1, and one of them is N2, second medium, which is velocity is V2. Okay. N1 divided by N2 is equal to V2 divided by V1. So you can see that N and V are inversely proportional. Suppose that medium 2 is air. So you know that refractive index of air is nearly 1. So you can write N1 divided by 1 equal to velocity of light in air is C. It means 3 times 10 to the power 8 meter per second. So you can write C divided by V1. So simply N is equal to C divided by V, as I wrote in this question. So I proved that N is equal to C divided by V if one of the medium is air. If both mediums are different and none of them was air, so you can use N1 divided by N2 is equal to V2 divided by V1. And you can see that this is normal. You can see that when light comes from denser to less dense medium, it goes away from the normal. So in air, in medium number 2, you can see that light goes away from normal because air is a less dense medium comparing to medium 1 in this example. Question 7. Figure 7.1 shows a coil of wire wound on a thin plastic cylinder. The plastic has no effect on any magnetic field, and galvanometer is extremely sensitive. A magnet is fixed to a small trolley that runs without friction on a track through the cylinder and coil. Part 1. The trolley is released from point A, so it runs through the coil from right to left. State and explain what is observed on the galvanometer. Okay, first of all, I wrote reason of that. You don't need to write an exam, so this part is extra. Your answer will be only deflection, then reverse deflection. So why? When magnet is moving towards coil, like pole is created on coil. Why? Because of Lenz's law. When it is passing coil and coming out from another end of the coil, unlike pole is created based on Lenz's law. So based on Lenz's law, when magnet comes towards the coil react about this motion because of Lenz's law and create like poles to decrease the speed of magnet, and then when light passing coil and coming out from another end of the coil, again based on Lenz's law, coil create unlike poles to attract magnet because of Lenz's law. That's why first of all you can see deflection, and then when magnet passing from the coil and moving out from the coil, so you can see reverse deflection. So you can write for this question, you can write deflection, then reverse deflection. You can get your mark. The trolley is now released from point B. So it runs through the coil from right to left again. State what is observed on the galvanometer and explain why it is different to your answer in AI. So point B is above point A, so you can see that potential energy at point B is more. That's why near the coil a speed must be more, and when a speed is more, you can see more induced current on coil, and deflection must be larger. So you can write larger deflection because of higher speed, and you know that larger rate of change of magnetic field causes more induced current, or you can write voltage. So you can get 2 marks for this part. Next part. Figure 7.2 shows an extension LED used to supply power to a 3 kilowatt electric heater on a cool evening. State and explain 3 dangers with this arrangement. So if you look at arrangement, first of all, power is too high. It is 3 kilowatt. It is 3 kilowatts. It is 3000 watts. So it is too high, and that's why some part of the insulation cut, so caught in out of insulation, so it causes a danger of electric shock. Danger 2, overheating in extension LED. Overheating in extension LED. This is the second danger. And the third one, you can see that shock through plug on damp or caught in insulation. So these are three important dangers for this arrangement. Question 8. A wire of length 2 meter and cross-sectional area 0.40 millimeter square has a resistance of 0.14 ohm. Calculate the resistance of another wire of the same material of length 3 meter and cross-sectional area 0.90 millimeter square. You know that resistance is directly proportional to length of the wire and inversely proportional to cross-section of the wire. That's why R2 over R1 for two wires is equal to L2 divided by L1 times A1 divided by A2. So L2 is 3, L1 is 2, A1 is 4, and A2 is 9. So R1 also given 0.14. If you substitute, you will get 0.093 ohm. So R2 will be 0.093 ohm. Second part, a student is designing a digital electronic circuit. Figure 8.1 shows her partly completed design. Table 8.1 is a truth table. Complete the columns in this truth table to show the values for input B in the circuit. First of all, look at NOR gate. This is truth table for NOR gate and AND gate. For NOR gate, if input A is 0, input B is 0, the result is 1. Otherwise, result is 0. So for any other condition, result output is 0. For AND gate, if A and B are 1, then output is 1. Otherwise, it is 0. So you should remember that. In NOR gate, if two inputs A and B are 0, output is 1. In other situation is 0. In AND gate, if both of them are 1, output is 1. Otherwise, output is 0. So now check this figure. So every color, I suppose that every color shows one row of this table. So for example, I check blue color. So input A is 1, input C is 0, and input D is 0. Look at only blue digits. So input A, C, and D are given. So input A is 1, input B is not given, then output C is 0 and output D is 0. So you should find input B for blue digits. Okay. Look at this gate is NOR gate. The above one is NOR gate. So look at NOR gate. When A is 1, so A is 1, So last two situations, this is A is 1. If output is 0, then B can be 0 and 1. So B can be 0 and 1. Now look at output D. Output D also is 0. And and this gate is AND gate. Look at AND gate. So input A is 1. Now for AND gate. Input A is 1. Output is 0. Look at AND gate. Input A is 1 and output is 0. So what is B? B should be 0 for AND gate. So B is 0. So write 0 in first rows. In first row, write 0. So input B is 0. Now check second row. Again, input A is 0. Input A is 0. Input C is 0. Input D is 0. Okay, now look at point C, because point C is in NOR gate, output of NOR gate. So input A is 0. Input A is 0 for NOR gate. And now look at green digit. Input A is 0 and output of C is 0. So if you look at NOR gate truth table, input A is 0 and output is 0. So you can write 1 and 0 for NOR gate. Okay, now check 1 or 0. Now look at AND gate. Output of AND gate is D. So again, A is 0, A is 0, and D also 0 for AND gate. So output is 0 and A is 0. So A is 0, output is 0. So you can see that you can choose 1. So green is the answer for 1 will be answer for input B for second row. Now third row. Input A is 1. Input A is 1. Now look at yellow. Input A is 1. Then point C is 0. So look at NOR gate. A is 1, output is 0. So can be 1 and 0. Is that right? So B can be 1 and 0. Now look at AND gate. Input A is 1 and point D, which is output of AND gate, is 1. So look at AND gate truth table. It should be last row. 1, 1 and output is 1. That's why input B should be 1. Look at this one. 1, 1. The output will be 1 for AND gate. So you can see that B must be 1 for third row. Now look at the last one. It is written by red. Input A is 0. Input A is 0. C is 1. Okay. Now look at NOR gate. In NOR gate, A is 1 and output is 1. So we have only one condition for that. So A and B must be 0. That's why you should write for B 0. Okay, next question. Describe what is meant by the term electric field. So region which has an electric charge experience a force. This is meaning of electric field. Figure 9.1 shows two parallel conducting plates connected to a battery. On figure 9.1, draw 5 lines to show the electric field pattern between the two plates. You know that between two metal plates, electric field lines must be parallel and equally spaced, because electric field is constant, is uniform. That's why electric field lines must be parallel and equally spaced. So draw 5 lines, and you should consider that larger end of the battery means positive and a smaller one means negative. So this is positive plate and this is negative plate. So electric field should start from positive plate and end to negative plate. So arrows are important. Arrows should be from positive plate to negative plates. Part C. When fully charged, a 1.2 volt rechargeable battery can deliver a current of 210 milliampere for 10 hours. Calculate the charge that can be delivered by the fully charged battery. So you know that charge is equal to IT. I is given 210 milliampere, so change it to ampere, times 10 hours, which is 10 times 3600. We can get 7560 coulomb. Calculate the energy stored in the battery when fully charged. You know that energy is equal to Q times V. Q is 7560 times V is 1.2, so you will get 9100 joules. State the type of energy stored when the battery is charged. So you know that it is chemical energy. Question 10. The nucleus of a hydrogen atom is a proton. The mass of the proton is m, and the size of the charge on the proton is E. Complete table 10.1. Okay. So for proton, mass is m and charge is E. For neutron, charge of mass of neutron is nearly equal to mass of proton. That's why you can write m, and you know that neutron doesn't have charge, so charge is 0. For gamma ray, mass is nearly 0 and charge also is 0. For nucleus of helium, mass is 4 times mass of protons, because in nucleus of helium there are 2 protons and 2 neutrons. That's why 2m plus 2m will be 4m. So for helium you can write 2m plus 2m, so mass will be 4m. And charge is 2e because it has 2 protons and charge of 1 proton is E, so 2 protons means 2e. Part B. Many schools and colleges use radioactive isotopes for teaching and research. Describe how these radioactive isotopes are handled, used, and stored in a safe way. So first of all, you can say that minimize exposure by time, so when you don't need to use them, so put them away. The second one, use of tongs for handling, protective clothing, and monitoring exposure. So these are, you can write 3 of them. These are important points about handling and using and storing radioactive isotopes. I missed one part of question 8. It is said that the column O in the truth table shows the desired output values for the circuit. On figure 8.1, complete the circuit to achieve these output values. Label any gate used. Okay, look at point C and D. Now point C and D are input for output O. So if point C and D, both of them are 0, the result is 1. If one of them is 0, the result is 0. If you look at NOR gate truth table, you can see that if both inputs is 0, so output will be 1. So this is NOR gate. That's why I draw NOR gate. This is NOR gate. You should draw to get 2 marks. So also this is NOR gate, and this is AND gate. So this is one part which is missing in question 8. I would like to explain one of the part of question 8 again, so separately. So suppose input A is 1, so input A is 1 and output C and D are zeros. So look at NOR gate and truth table for NOR gate. If A is 1 and output is 0, you will have 3 choices. 0 and 1 is 0, 1 and 0 is 0, and 1, 1 is 0. So for NOR gate. Then look at AND gate. So if A is 1 and output of D is 0, A is 1 and output is 0, you can choose 3 situations: 0, 1, 1, 0, and 0, 0. Now, you should find B. So, if you put 0 for B, now check output C and D. Input A is 1, input B is 0. Okay? 1 and 0, so output for NOR is 0. So this is right. Now check for D. A is 1 and B is 0. For AND truth table, 0 and 1, the result is 0. So look at D, D is 0. So for input B, you should put 0. For input B for second row, by chance I will write 1 and I will check it. If it is wrong, then I put 0. For example, input A is 0, input B is 1. So 0 and 1, 0 and 1 for NOR gate, the answer is 0. So look at this, answer is 0. Now for output D, 0 and 1 for AND gate, look at truth table of AND gate, 0 and 1, the result is 0. So this is 0. That's why 1 is right. You can do it by chance, write it 0. If it doesn't happen, so then change it to 1. Thank you very much. If you have any question, you can ask me from YouTube. Goodbye.